In the last tutorial, we were discussing the GM over ID technique, and we did the uh, simulation and we did the characterization of MOSFET, and we plotted the GM over ID curves in Cadence. And in this tutorial, we will plot all those curves in Matlab. So let us see how we can plot this in Matlab. So to plot the curves in Matlab, first we have to export the data to a file, and in Matlab we will load that file and we will manipulate that file to plot all the required curves. So we have the setup here. So if you don't know how we reached to this point, I request you to watch our previous session. In that session, we did all the detailed characterization of NMOS and PMOS, and this is what we got. This ADEL window this we got from our previous session. So in this session I am starting from here because the how we reached here is already available in the previous session. So we have this setup here. For just sanity check, you can run this simulation, and you can see all the parameters in the plot. Yeah, we have all the parameters, and now we are not interested in plotting in Cadence. We are interested in saving the data to a file and accessing the file in Matlab. So for this also we need a little bit help from the Ocean script, and it is very easy to get the Ocean script. We need not write the Ocean script. We can save the Ocean script of this simulation. So I am saving that this save Ocean script, and in the name I'm renaming it as NMOS GM over ID. I am naming as NMOS. I am naming it as NMOS GMID dot OCN. Okay, save it, and you can see this is the file. So I'm closing this here and I'm opening the same uh, in another editor. So you can see this is our file nmosdmid.ocn. Open in gedit, and we can see it. So we are familiar with this Ocean script also. In the last session we discussed this Ocean scripting, and we added some extra commands here to plot the all the graphs in Cadence itself. So, but here we are not using that. Here our target is to save the data, save our required data to a file and access the file from Matlab. So now the command what we need is to export the output to a file, export the required data to a file. So the command for that is, so the format is OCN print bracket output space. And now we have to give the location and the file name where we want to save the file. So you can give any location and file name. I am giving my location as my the simulation directory. So I copy that and I just simply save the uh, destination. Here I want the data as nmos dot dat. So so here it will say, so it will be saved in this directory in the name of nmos.dat. So this dat file we will access from Matlab. So the code is not over. After that we have to write what are the code, what are the data that, what are the, after this we have to write what are the parameters that we require to extract. So we need not save all the parameters to the file. We can save only what the parameter that is required to us. For that, the code is, so we have to close this. Then the code is get data because the D is capital, bracket. Now here we need, this format is important. We need M0 is the name of the MOSFET. We need ID of M0. We should make sure that the name that we are giving here should exactly match with the name what we can see here. Here in the DC you can see all the names. So these parameters is what we are trying to save. So this name should match with what the code we are writing here. So ID is small I and small d should be exactly same as here. This one. So if I keep only this, this will write only the ID to the file. It will write, we are sweeping the VGS in the x-axis. So it will write VGS and it will write the ID according to this. But we need more number of parameters. And so next parameter I want is the GM. So I just copy this file, this line and paste once again and rename this to GM. So it will write ID and GM. Once again, after the GM, I need GDS, and after GDS I need CGG. And is there anything we need? You can put any number of parameter that you need. So I will add one more, that is the VTH, threshold voltage, and we can close this bracket. So we open this as the output here. Now I am closing this. So we are almost done, and we will get these parameters in the file. We will get ID, GM, GDS, CGG, VTH. If you are interested in any other parameter, you can simply add this here, add any number of data you want to add. But I'm saving only this much file and save this. Now I want to run the Ocean script. So load. It is nmos underscore gmid dot ocn run. So it is running the simulation, and hopefully it will write the file also. So once the simulation is over, we can check our file. So we are not interested in this data anymore. We can go to the simulation directory. This is where I asked to write the file is nmos.dat. So let us open it, and you can see all the value here. This is the DC value that we sweep. So this is our VGS, this is our ID, this is our GM for different VGS, this is our GDS for different VGS, this is our CGG for different VGS, and this is our VT for different VGS. So here I am seeing one difficulty, that it is using a character N to indicate the nanoampere, and then micro N U to indicate the microampere and all. So I want the notation to be in scientific, so that it will be easy for me to analyze in Matlab. So I want to add that information here. So after the file name, before entering what are the parameters that we need, we can ask the Ocean script to change it number format. The code for that is number notation scientific. And let us say, so here here it is, the format is the question mark. Save the file, and let us run once again. open the file, NMOS that. Now we can see all this nanometer and sorry, the nanoampere is, and milli are disappeared, and we got all in the scientific terms. So now we have the NMOS parameters, GM, ID, and all, and the first column is the VGS, second column is ID, then GM, GD, and all. So when we load this into MATLAB, this first line will be problematic because it is easy if the file contains an entire matrix, just matrix without any character, it is easy to load and analyze the data. But in MATLAB, if first line, if some other line contains character and all, it is difficult to extract first line and then second line and all. So if you are an expert in MATLAB, you can write the code to do that. You can write the code just to load from here and all the result. But since I'm not an expert in MATLAB, what I prefer is to delete the first line and make things easy. So now my file contains only the data, but I know this. We have to ensure the order. We have to remember the order we wrote into the file. So the order is first column is VGS, second column is ID, third column is GM, this is GDS, this is CGG, and this is VTH. So I modified the file like this and I saved it. Now I will open this in Matlab and I will plot. So before going to Matlab, I want to plot the same Cara for the PMOS also. So I'm closing the dat file and I'm closing, okay, NMOS GMID ocean script, let it be there. And let us close the NMOS and open PMOS. I'm not closing this file because I want to reuse this line. So it's the same code, we can just copy paste. So the PMOS, I'm opening the PMOS Cara here. So run it. It is working. Now, as usual, take the ocean script. Now I'm naming it as PMOS underscore GMID. Okay, close here and open the PMOS underscore GMID ocean. Now I'm not doing any change. I'm just copying this file, this line. I'm copying this line and paste to the PMOS. Everything is the same. We are using the same M0. In the PMOS also, we are using the MOSFET name is M0. Let us verify it. So it will extract. So it will extract the value, the ID and everything of M0. So the only difference I want to make, instead of nmos.dat, I want to make it pmos.dat. So save this and I will run here. It is pmos underscore gmid dot ocean. So just run it and we will get the data for the PMOS also. Let us close this and find our file, which is it should be pmos.dat. Open the file. So here the first line is VGS, then current ID. Current is negative as we expected, and the VTH also negative. Here also the order is same. And as I explained earlier, here also I would like to delete my first lines and only I need only the data so that it is very easy to use the file in MATLAB. So I repeat it, if you are an expert in MATLAB, you need not do this. There are many ways to to avoid the first lines, but I'm not so familiar with MATLAB, so I'm using this shortcut. Save. Now we have the two files, that is nmos.dat and pmos.dat, uh, ready with us with the parameters for the characterization of nmos and pmos. Now we can go to Matlab and the plot the parameters for plot all the GM over ID curves. We extracted the parameters from MOSFET using Cadence and we saved them into a data file, and now we are trying to plot them with Cadence. So, oh sorry, now we are trying to plot them with Matlab. So, these are the two files that we have for NMOS and PMOS, and this is my directory in which I copied these data files. So in the Matlab, first I want to add the path of in Matlab first I want to add the uh, path of the data file. So I am doing this, add path. So this is where my files are in. So it is the location of the files. Now I want to load the file. So load, the file name is nmos.dat. So let us run now itself so that we can find any uh, mistake in the script. So I am naming it as nmos.m and save it. Trying to just run. So here you can see the nmos, it came. So it is 51 into 6 matrix. So if you want to see the value, you can see that. So the first column is VGS, second is ID, then GM, and so on. So now I want to extract all these values, and before extracting I would like to add a variable W, that is the width. So I'm defining width equal to 5 micro. That is not changing in any of our simulation, so I can directly give the W as 5e minus 6, that is 5 micrometer. Now I want to load ID. ID is the current, so that is the first column in this nmos.dat matrix. So nmos.matrix we already have here, so we have to load the first column. ID will be the second column. So before ID I want to add VGS. So we know VGS is the first column, so VGS equal to, I'm putting the standard matrix form, and here we have to put the same name, that is nmos. Nmos represent the file name in the bracket. So this command will save the first column of this nmos matrix, first column of this nmos matrix to the VGS. So VGS also will be a single column matrix. So just run this. So so we got our VGS now. So if you want, we can see our VGS. So VGS is the first column in the nmos dot dat. Now the second column we know it is ID, so I want to save ID equal to similar to this, just copy paste. Only the difference is now we want to, that is the second column. Now the second column is ID, and similarly you can just copy paste for the third column, that we know the third column of this file represents the GM. So this is 3, and the fourth column represents GDS. So here is the fourth, and the fifth column represents, I think the order was after GDS, that is CGG. So that is the fifth, and the last column, that was VTH, so that is 6. Okay, now we have all the values here: CGG, GDS, GM, ID, and VGS and VTH. Now we can write the expression whatever we want. For example, the GM over ID, that we can write GM and ID equal to, so we have GM here, this is a GM divided by ID. So if you write this GM divided by ID, it will do a matrix division, but we don't really want a matrix division, and it will show error because our number of rows and columns are different. So what we need is element by element division. So I can use this operator, so that I will get GM over ID as a GM. Each column of GM will be divided by corresponding each value in the GM column will be divided by corresponding value of column in the ID. So this GM over ID I can get I got it without much error. So you can see this GM over ID, I got the matrix as I got it as a single column matrix here, GM over ID. Similarly, the next parameter I am interested is VOV, that is overdrive voltage. So VOV equal to, we know it is VGS minus VTH, VGS minus VTH. Can run that, and you can see VOV is also here. According to our calculation, it should start near to 200 minus 200 millivolt. It is VGS minus VT, and after VOV, what we are interested is GM by GDS. So that I am representing as GM underscore GDS. GM by GDS equal to GM divided by GDS. It is a similar way that we did GM over ID, and after GM by GDS I am interested in FT. So FT equal to, the expression is GM by 2 pi CGS. So we can write GM divided by 2 pi CGG. FT is defined as GM by 2 pi into CGG. Now the remaining parameter is ID by W. So ID underscore W equal to ID divided by W. So W we already defined here, W is 5 micro. So let us run the values till now, and we got it without much error, without any error, and all the values are here. Now we can start plotting. So before plotting any of the GM over ID curve, I just want to start with a simple plot, that is let's plot ID versus VGS. So I want to plot VGS ID. So let us plot it. So this is a VGS over ID curve, I just wanted to make sure that our VGS and ID came as what we expected, because we sweep VGS from zero point 0.2 to 1 volt, so it is the same that we are getting. In reality, we are not interested in a VGS ID versus VGS plot. So really speaking, we are more interested in to see a plot between VOV and GM over ID. So let us plot this. So this curve is familiar to us. This is x-axis the VOV and y-axis the GM over ID. So we can indicate the axis in Cadence. Cadence is a very powerful plotting uh, software. So you can label this. So I'm x label. I'm giving overdrive voltage, that is VOV. So the unit also I am giving as volt, and similarly you can give the Y label also. Y label is GM over ID. So that is our X label. Similarly our Y label is GM over ID, and 1 by V is the unit. So let us run our code again. So here it oh sorry, both of them we labeled as X label, so rename this as the Y label. Run. Yeah, here now we got the GM over ID and VOV here. The next plot, we will try to plot different values with respect to VOV first. So to have multiple plot, we have to use subplot. So I'm using the subplot option here. Initially let us have 2 by 1, so 2 1 1. This is what we, our first graph, that will be GM with respect to VGS, and our second plot will be, we want FT with respect to VGS, VOV. So I am writing the FT here, subplot 1 2 by 1. This is the second plot, so let us plot it. So we got FT with respect to VGS and FT with respect to VOV, and GM over ID with respect to VOV. So I am trying to have 4 plots, so I use subplot 2 by 2 1, 2 by 2 2, and copy paste 2 by 2 3. In third I want GM by GDS, so I just replace FT by GM underscore GDS. Here also it is GM by GDS, and one more plot we can have. Let's save some space over here. So it will be the fourth plot that I need. What we did, FT, and let's plot ID by W, so that is ID underscore W. Here we can write ID by W. So all of them, the x-axis is VOV and the y-axis we gave the different parameters. So let us see all the graphs together. So this is the 4 graphs, and really speaking, instead of ID by W, we are more interested in FT into GM over ID, so that is also an important parameter. So let us plot that. So before plotting, we have to derive that function. that is ft into gm over id, so that equal to, so let's ft we already have, so copy, that is ft into gm over id also we calculated here, so we can copy paste that also. Let's run. So before running I want to plot that, so let's plot. So it is ft into gm over id. Let's plot. So now we got all these four different parameters, so you can plot whatever parameter you want, you can plot from here. So now we plot everything with respect to VOV. Now I want to plot everything with respect to GM over ID. So GM over ID I copied. So let the first plot it be GM over ID with respect to VGS. So second plot I want GM over ID with respect to FT with respect to GM over ID. Then GM by GDS with respect to GM over ID. Then FT into GM by ID with respect to GM over ID. And the axis name also I want to change. So all the Y label, sorry, all the X label should be GM over ID now. Let's copy VOV. I am replacing with the GM over ID so that the x-axis comes to GM over ID. Okay, let's run the simulation. So this how the graph different graph look like for the NMOS. This is GM over ID with respect to VOV. This is FT with respect to GM over ID. This is GM by GDS with respect to GM by ID, and this is FT into GM by ID with respect to GM by ID. So this is one important part of the our objective to plot all the GM over ID curves. So we did this for the NMOS. So similarly we can do for PMOS also. For the PMOS I am just copying this, copy. So I am saving it as pmos.m. Save it and just paste all the code. So let us see what are the changes that we have to make. Add path is same. Instead of nmos dot we have pmos dot dat. Rest of the things is everything is the same. W we use the same. So VGS is the first column, ID is the second column, GM is the third column. So everything should be the same. The only difference is our ID will be negative. So let us plot and see how the graphs comes, and if something comes negative we can change that to positive. So with respect to GM over ID we need not change anything. Everything is everything is good in good shape. We have GM over ID with respect to VOV. All these are for oh sorry, before moving we have to change all these. Now everything will be saved from NMOS. So before that, so before plotting anything we have to change everything to PMOS. All the NMOS should be replaced with PMOS. So that is a mistake that we did. So let us make it PMOS everything. So I don't think we have any NMOS left here. So everything is with respect to PMOS, and just run the simulation. So the FT, so this GM over ID curve we have negative here. This because the ID is negative for PMOS. Similarly this FT into GM over ID also we have negative. So it is hard to analyze if the graph is uh, not in the correct shape. So let us change all these negative values into positive, so that we can simply add a negative over here, I think. And gm over id also we can have a negative. So let us plot it. So now these graphs are something like familiar to us. So this is what we expect for gm over id curves, graphs for different for these are the different GM over ID graphs for the PMOS. So now we completed all the GM over ID graphs for NMOS and PMOS for a single length. Now we assume the channel length is 180 nanometer, so we didn't care about the channel length. But really speaking, for the GM over ID curves, we have to plot the GM over ID curves for different channel lengths. So for that we have to sweep the channel length and get the data for different channels, get all this data for different channel lengths. So we can go to cadence and generate the files once again for different values of channel length, and let's load those files. Let's go to cadence and uh, characterize the MOSFET for different channel lengths and save the data in a file.